Hello, good morning. In this video, we are discussing about one more important application of the low range transformation. One thing we are learning, right? Special theory of relativity. It is not just easy. It is the advanced topic in the classical mechanics because Einstein introduced this theory. Before going to introduce the Einstein, I told the first class itself the introduction of the special theory of relativity, how the Newtonian mechanics came, how the Galilean introduced the transformations. Galilean transformation, we also call it as a Newtonian transformations also. So, Galilean transformations not executed in electromagnetic waves, that is why low range introduced the transformations. So, those transformations are we discussed in the previous class. After deriving the low range transformations, we are going for the application of the low range transformations. In the application of the low range transformation, the first application we discussed about the length contraction. The second application we are discussing about a time dilation. The third application we are discussing about the so which one we are simultaneity. The fourth application is addition of velocity. This is very important. Maybe in the next class we have to discuss about what is the which one, what are the things behind the theory, that is the low range invariant phenomena. What are the low range invariant, how we discussed about the Galilean invariant, the same way low range invariants also we have to discuss in the tomorrow's class or next class we have to take. Clear? So, this is very important applications, compulsory, you will get it in your competitive exam, not only in CSIR exam, any competitive exam, these are very important to you. So, please concentrate and practice, otherwise nowhere you will get such type of explanation in any app also, because throughout the year no one can teach to you, because in mathematical methods of physics I told you throughout 6 months, maybe 103 days I told you. So, no one can teach you like that. Clear? So, maybe in the month of January onwards, so I am keeping the target in the month of January I have to wind up the entire classical mechanics. So, little bit past I have to teach morning and evening also, night also have to take the class. So, do not worry, I will finish the syllabus in time only. In 2025, all 2025 I kept the target. So, I will finish the syllabus, at least I will finish the syllabus to get the notification of the DL or JL, any notification, maybe July is there, no, the 7 months is there, within the 7 months I have to wind up the syllabus. So, do not worry. Now, you able to see what is the addition of velocities. Once you have to see the application of the low range transformation. This is the fourth application of the low range transformation, that is the addition of velocity. Let the coordinates of a particle in frame S, you have to take the coordinates of the particle. Suppose you have to take, this is the S frame, right, S frame. So, let the coordinates of a particle, say in the S frame there is a coordinate is there, that coordinate of the particle you have to take x comma y comma z comma t. This is the Minkowski space. So, let the coordinates of a particle in S frame be x comma y comma z comma t, and S dash frame, one more frame is there. So, what is that frame? So, this frame is the S dash frame. So, that coordinates of that particle is equal to x dash comma y dash comma z dash comma t dash. Along the x dash axis is this one is along the x axis we are parallel to this S and S dash frame. Let the coordinates of a particle in S frame be x comma y comma z comma t. In S dash frame x dash y dash z dash t dash. Then the components of its velocity in two frames can be written as. Then the components of its velocity. Suppose if you have to take the components of velocity ux comma uy comma uz, these are the coordinate ux comma uy comma uz, or u x you have to take along the x axis u x, or so you have to take, generally you have to take as a u in S frame, right. The similarly what you have to take here, so this u x dash comma u y dash comma u z dash comma, so u z dash u x dash u dash u x dash u y dash u z dash comma u t dash is there. Which one you have to take? U t dash you have to take, this is the which frame it is, that is S dash frame, their velocities of that. How we have to related these things, this S dash is frame is moving with velocity v. This is the information and introduction to get the addition of velocity. Let the coordinates of a particle in S frame be x comma y comma z comma t. Suppose you have to take one person is sitting here, right. So, is a person may be at particular point P. This person is observing, let the coordinates of a particle in S frame be x comma y comma z comma t, in S dash frame x dash y dash z dash t dash, then the components of the velocity u x comma u y comma u z and u x dash comma u y dash comma u z dash comma u t dash is there. These are the components of the velocities, clear. So, now this S dash frame is moving along the x axis with respect to S, how much velocity it is moving with v velocity is moving, clear. Now, the particular person is sitting at particular point, that point is a P point, is observing the S frame, is observing the S dash frame, now is recording all these things. Once you have to see that one. Suppose if you have to take the low range transformations, according to the low range transformation, you know that according to the low range transformations, what are the low range transformations? Once you have to see, according to the low range transformations, so what are those low range transformations? You have to see, according to the low range transformation, x dash is equal to gamma into x minus v t, x dash is equal to gamma into x minus v t. So, now you have to differentiate explicitly. So, you have to differentiate implicitly, implicitly you have to differentiate above the expression dx dash is equal to gamma into dx minus v into dt. So, this is the dx dash value you have to remember. From the low range transformation, we have to write x dash is equal to gamma into x minus v t, differentiate implicitly. This expression v is the constant speed, it is going the S dash frame with respect to S. So, therefore, the differentiate implicitly above the expression you able to get dx dash is equal to gamma into dx minus v into dt. So, once you have to get that one, so once you have to see what we are getting, once you have to take x dash is equal to, again I am writing, once you have to see ex minus v t, x dash is equal to x minus v t, dx dash is equal to gamma into dx minus v into dt. So, this is the equation number 1 you have to take. Which one you have to consider? It is equation number 1. Now, y dash is equal to y dash is equal to y according to the low range transformation, dy dash is equal to dy, and similarly you have to take z dash is equal to z. So, therefore, you have to differentiate implicitly dz dash is equal to dz, you are getting dz dash is equal to dz. Now, you able to take so t dash is equal to gamma into t minus vx by c square. So, gamma into t minus vx by c square. Therefore, you have to differentiate implicitly dt dash is equal to gamma into dt minus v into dx by c square, v into dx by c square. So, which one it is? This is the equation number 2 you have to take, right. Once you have to take the equation number 1 and equation number 2 you have to take here. right. So now you have to observe what you have to observe, the ones you have to see here. Therefore, we have these are the low range transformations. According to the low range transformation, the position coordinate I have to write here, the time coordinate I have to write in the equation number 2. Now we have to calculate the velocity components. How we have to calculate the velocity components? Ux dash is equal to, which one we have to write here, dx dash is divided by dt dash. So ux dash is equal to dx dash is divided by dt dash. So therefore you have to substitute the equation number 1, dx dash is equal to gamma into dx minus v into dt is divided by dt dash is equal to gamma into dt minus v dx is divided by c square, v dx is divided by c square. This is the substitution of equation number 2 and equation number 1. Now you have to take the cancelling gamma, gamma you have to take the cancel. Now you have to bring the dt inside, outside of the bracket. So therefore dx by dt, so minus v is divided by, so you have to take here also you have to take, which one you have to take the common, you have to bring it dt, you have to bring the common, outside you have to bring 1 minus v into dx by dt is divided by c square is there. So from this what you have to write, dx dash is equal to dx dash ux dash is equal to, or u dash x is equal to, which one we have to write, u dash x is equal to, or ux dash is equal to, so dt dt get cancelled. So therefore dx by dt minus v is divided by 1 minus v by c square into dx by dt. But you know the dx by dt, this is the velocity in coordinate in the frame s frame. So ux is equal to, now you have to write ux is equal to dx by dt, you have to take ux is equal to, therefore ux dash is equal to, which one we have to write here, ux minus v is divided by 1 minus ux into v is divided by c square. So this is the velocity component along the x axis. Which component it is? Velocity component along the x axis. This is the equation number 1 you have to write. Clear? So this is the equation number 1, velocity component along the x axis. Similarly, if you have to calculate the uy dash also you have to calculate. So what are that uy dash? Once you have to see, uy dash is equal to dy dash is divided by dt dash. This is very important, please concentrate on this. So dy dash is equal to dy, you know this. So dt dash is equal to gamma into dt minus v into dx is divided by c square, correct? So now I am substituting the equation number, dy dash is equal to dy, dt dash is equal to gamma into dt minus v dx is divided by c square. Now from this we have to write, so dy is divided by gamma into, you have to take the dt outside, 1 minus v into dx is divided by c square into dt we have to write. Clear? Now I am rearranging the term. So dy is divided by dt, this denominator I have to take to this side. So now we have to write, this is 1, right, is divided by gamma into 1 minus so v by c square into dx by dt, v by c square into dx by dt. But you know that, so what you know one thing, uy is equal to uy, this is the velocity in s frame along the y axis. So that is equal to dy by dt, correct? Uy is equal to dy by dt. but gamma is a low range factor. So what is the low range factor? You know that low range factor, right? Gamma is the low range factor. Gamma is equal to 1 by square root of 1 minus v square by c square. Gamma is equal to 1 by square root of 1 minus v square by c square. So similarly, ux is equal to dx by dt. So these values you know, all these values you know. So that's why we know that. So you substituted these values in this expression, you able to get. So what you are getting once you have to see uy dash is equal to dy by dt is equal to uy. So uy is divided by 1 by square root of 1 minus v square by c square. 1 minus v square by c square. Again you have to take beta is one factor, we have to take it as a beta is equal to, that is the ratio of the velocities, v by c if you have to consider. Then you have to write here. So how we have to write? Once you have to see 1 minus v into ux is divided by c square. So therefore what we have to write here, once you have to see uy dash is equal to uy into, so uy into 1 minus v square by c square is divided by 1 minus v ux is divided by c square. So this is the uy dash. This one you have to take it as a equation number 2. You have to consider as a equation number 2. The similarly, if you have to take the uz dash along the z axis also you have to consider, because our space is Minkowski space. uz dash is equal to, which one you have to write? So dz dash is divided by dt dash, but you know here dz dash is equal to dz, but dt dash is equal to gamma into dt minus v into dx is divided by c square. This is the equation number 2. I have to substitute the dt value. Now again you have to follow the similar procedure. Gamma into dt you have to take outside, 1 minus v by c square into dx by dt, v by c square into dx by dt. I am rearranging this one. dz is divided by dt is divided by gamma into 1 minus v by c square into dx by dt, 1 minus v by c square into dx by dt, which is equal to uz dash. Clear? So but you know that similarly you know that uz is equal to dz by dt, ux is equal to dx by dt. The low range transformation, what is the low range transformation, low range factor? Gamma is equal to 1 by square root of 1 minus v square by c square, but beta is equal to v by c. You know all these values, you have to substitute these values in this expression. You are able to get uz dash is equal to, which one we are getting? Once you have to see uz dash is equal to uz into, so is divided by 1 by square root of 1 minus v square by c square into, so 1 minus v by c square into ux is there. So ux is there, then you have to rearrange this expression. uz into square root of 1 minus v square by c square is divided by 1 minus ux into v by c square. So this is the, so which one it is? This is the equation number 3. So these are the velocities in S dash frame. So we discussed these 3 velocities. Once you have to see the 3 velocities, what are those velocities? You have to conclude this. Ux dash is equal to, ux dash is equal to, you are getting ux minus v is divided by 1 minus v into ux is divided by c square. This is the equation number 1, right? So this is the equation number 1. The equation number 2 is uy dash is equal to uy into, so uy dash is equal to uy into So square root of 1 minus beta square is divided by 1 minus v into ux is divided by c square, v into u divided by c square, and again you have to take this is the equation number 2. So u z dash is equal to uz into which one we have to write, uz into square root of 1 minus beta square is divided by 1 minus v into ux is divided by c square. This is the equation number 3. Now you able to see, so these three equations we call it as a addition of velocity equations. These three equations we call it as, these are the low range transformations. It may be noted that the velocity components uy dash and uz dash is also depend on ux. Once you have to see here, in uy dash there is a velocity component is ux is there, in uz dash also there is a velocity component ux is there. So these equations we call it as a low range transformations of the velocity equations. These equations these are the low range transformations. It may be noted that the velocity components uy dash and uz dash, uy dash and uz dash are depending on ux. So the inverse transformation is obtained by, how we have to obtain the inverse transformations, once you have to see, right, how we have to obtain the inverse transformation. You have to write obtained by replacing v by minus v and interchanging the primed unprimed coordinates. So these equations we also call it as a relativistic law of addition of velocities. Relativistic law of addition of velocities. This is very important. How we have to write the inverse transformations, ux is equal to ux dash plus v is divided by 1 plus v into ux is divided by c square. This is the equation number 1. This is the inverse transformation of a low range equation, right. So one more equation you have to write, uy is equal to, so uy dash, so into square root of 1 minus beta square is divided by, which one we have to write here, 1 plus v ux is divided by c square. It won't be changed, so it will be like that only. This is the equation number 2. uz is equal to uz dash into square root of 1 minus v square by c square or beta square is 1 plus v into ux is divided by c square. This uz so component also belongs to the x component is there. So these are, what are those, these three we call it as a inverse transformation, low range inverse velocity transformations, low range inverse velocity transformations. How we have to write, we are so replacing v by minus v, we are replacing v by minus v, and primed coordinates we have to write into unprimed coordinates. Wherever ux dash is there, I am keeping as a ux, wherever ux dash is there, ux is there, I am keeping as a ux. So that ux dash, that is the way we have to calculate the velocity transformations. Clear? So once again you have to see, so what is the things behind this. So consider a particle at p which is moving with velocity u as measured by an observer in s frame. Suppose you have to take here, already we are discussing, once you have to see there is a s frame is there. So this is, there is a s dash frame also is there, right. So consider a p is a, you have to take one point, one person is sitting here. So that is the point sitting, that person is observing, once you have to see. consider a particle at p which is moving with a velocity u. So, consider a particle at p which is moving with velocity u as measured by an observer in S frame. This p person is measuring in S frame. What is that velocity? U. So, its velocity as measured by an observer S dash frame. So, what is that velocity? U dash, right? So, U dash. If U dash is along the x dash axis, U dash is along the x dash axis, this is the x axis if you have to take. So, therefore, what we have to consider here, u x dash is equal to u and u y dash is equal to 0 because the particle is moving along the x direction. U z dash is equal to 0, u z dash is equal to 0, u x dash is u y dash is equal to 0, u z dash is equal to 0. So, then what we have to write? So, this is very important. So, now with respect to S dash, what is the S dash frame velocity? S dash frame velocity is equal to v. Now, you have to see u is the velocity of the body with respect to S. What is the u? U is the velocity of the body with respect to S. What is the u dash? U dash is the velocity of the body with respect to S dash. What is the v? V is the velocity of S dash with respect to S. So, this is very important. Once again you have to listen. U is the velocity of the body with respect to S. U dash is the velocity of the body with respect to S dash. V is the velocity of S dash with respect to S. V is the velocity of S dash with respect to S. So, therefore, what we have to write here, once again you have to see our outermost equation, u x dash is equal to u x minus v is divided by, so u x minus v is divided by 1 minus u into v is u x into v is divided by c square, v u x is divided by c square. So, this is the equation is there, but according to this equation you substituted u x dash is equal to u dash, u x is equal to u minus v is divided by 1 minus v into u is divided by c square. So, this is the relative velocity. Which velocity it is there? This velocity we also call it as a relative velocity. Relative velocity. This velocity we also call it as relative velocity. Right? This is very important. So many times your competitive people are asking, find the relative velocity also, right? U dash is equal to u minus v is divided by 1 minus uv is divided by c square is there. So, if you want to write the inverse, so if you want to write these inverse equations, how we have to write the inverse? So, the inverse of these equations, once you have to take, I am writing as the inverse. So, how you have to write? U is equal to u dash plus v is divided by 1 plus uv is divided by c square. So, this is the inverse transformation. This is the low range transformation of Einstein equation, addition of velocities. This is the inverse of that equation. This is the inverse of addition of velocities, low range addition of velocities, low range addition of velocities, inverse of low range addition of velocity. So, that is why, so these equations, these are referred to as Einstein's law of addition of velocities. So, these equations we also call it as Einstein's law of addition of velocities, also we call it as very important to solve the problems. So, these two expressions are very important. So, these two expressions you have to remember, u dash is equal to u minus v is divided by 1 minus uv by c square, and u is equal to u dash plus v is divided by 1 plus uv by c square. This is very important. Please concentrate on this. Not only this, we have to discuss about the interpretation of these equation. How we have to interpret this equation? Suppose u dash and v are smaller as compared to c. Once you have to take u dash is equal to u minus v is divided by 1 minus uv by c square. This is ultimate equation. But what is our case? Our case is u dash and v are very small. So, u dash and v are very small if you have to consider. So, you have to take the inverse of this equation. You have to take u is equal to u dash plus v is divided by 1 plus u dash v is divided by c square. Now, you have to take here u dash is small and again v is small, it will become is to go to very small, right. So, now you divided by with c square, it will get absolutely neglected. So, you have to neglected this value. So, u dash v is divided by c square, you neglected this value. So, therefore, our expression will become, how it is our expression? Our expression will become u is equal to u dash plus v. So, this one we have to write, it is u dash is equal to u minus v. This u dash is equal to u minus v. What is this? This is exactly going to equal, that is a, so which one it is? Exactly going to equal Galilean classical equations. So, therefore, that is why these equations we call it as a Einstein's law of addition of velocities of the relativistic equations. We call it as, if you have to take u dash and v are very small, then u dash v by c square value is neglected. So, therefore, this u dash is equal to u minus v, u dash is equal to u minus v. So, therefore, these expression, based on this expression what we have to write. So, this expression is going to take as a Galilean, which one it is? Galilean equation. This equation is a Galilean equation. So, therefore, when v is much less than the speed of light, when v is much less than the speed of light, so we have to write the conclusion, when v is much less than the speed of light, when v is much less than the speed of light, then relativistic law of addition of velocities, then relativistic law of addition of velocities, relativistic law of addition of velocities to become a Galilean equations. Those Galilean equations belongs to the classical equation. That is very important. What are the Galilean equations? Once you have to see ux dash is equal to ux minus v, and uy dash is equal to uy, and uz dash is equal to uz. So, these equations are which equations? The classical equations, or Newtonian equations, or Galilean equations. Clear? So, that is why, so whenever the, when v is smaller than, v is much less than the speed of light, so these relativistic law of addition of velocities going to become a classical equations or Galilean equations or Newtonian transformations. Clear? So, that is the one important thing you have to remember. Otherwise, if you have to take one more interpretation of this relativistic addition of velocities, if v is equal to c, if v is equal to c, what will happen? Once you have to see, if v is equal to c, you have to take the expression u is equal to u dash plus v is divided by 1 plus vu is divided by c square. So, then you have to substitute if v is equal to c or u dash is equal to c, you have to take. So, which one you have to get here? Once you have to see, you c plus v is divided by 1 plus, so what we have to write? V is equal to c, I am writing. So, u is equal to c, v is divided by c square, 1c get cancel. Therefore, we have to write c plus v is divided by, in the denominator you have to take the LCM, c plus v is divided by c, c plus v is get cancel. Therefore, you are getting the u is equal to c. Which one we are getting? So, therefore, u is equal to c. So, this is very important. So, not only like that, whether it may be you have to take v is equal to c or u dash is equal to c, also you are getting u is equal to c only you have to get, clear. So, otherwise one more important thing, if v is equal to c is equal to u dash, if e is equal to c is equal to u dash, then how it will become, once you have to see u is equal to u dash plus v is divided by 1 plus v u dash is divided by c square, 1 plus v u dash is divided u is divided by c square, 1 plus v u dash is divided by c square. Here also you have to take here, so u dash, so you have to consider as a u dash now. So, 1 plus v u dash is divided by c square if you have to take. Now, you substituted how u is equal to u dash is equal to c, v also c is divided by 1 plus v c into c is divided by c square. So, c square get cancelled. So, therefore, c plus c is equal to 2c. So, 1 plus 1 is equal to 2. So, 2 get cancelled, therefore, you are getting the c value. So, they in the two cases you are getting as a c, u is equal to c value you have to get. From this, what we have to conclude, thus the speed of photon in the second frame is also c, that is the velocity of the light is the same for all inertial frames. So, wherever whatever their relative speeds may be, so whatever their relative speeds you have to take, that light velocity is same wherever you go. So, this is the light velocity. That is how there is Lorentz equations satisfies the Einstein's postulates. So, this result is according with the Michelson-Morley experiment. In fact, the Lorentz transformations and hence the law of addition of velocities have been deduced by assuming the velocity of light is constant for all inertial frames. So, this is the law of addition of velocities. The law of addition of velocities have been deduced by assuming the velocity of light constant for all inertial frames, clear. So, this Lorentz addition of velocities, by using the Lorentz addition of velocities, we are deducing the concept of postulates of the special theory of relativity, that is the velocity of light is a constant in all inertial frames of reference. So, that is the velocity of the source does not add anything to the velocity of the light, the velocity of the source does not add anything to the velocity of the light emitted by it. In other words, so it is impossible to exceed the velocity of light by adding 2 or more velocities, no matter how close each of these velocities are to that of that light, clear. So, that is the thing we have to discuss. So, this is the conclusions based on these addition of velocities. So, not only these conclusions, the speed of light in a moving medium. So, how we have to calculate the speed of light in a moving medium. So, that is very important once you have to see. First, you have to consider S frame, you have to consider S frame, you have to consider this is the S frame, right, S frame, you have to take the S frame, and one more frame you have to take, this is the one more frame, S dash frame. This S dash frame is moving with velocity v. So, that velocity v, now you have to consider as a that velocity, it is in the liquid or water if you have to take. So, which one you have to take in S dash frame is in the water, is S dash frame is moving in the water, clear. So, how much velocity? This velocity is Vw. S dash frame is moving with the water, that velocity we have to take, it is the water, clear. So, now you have to take here S frame velocity, you have to take it as a u, S dash frame velocity you have to take it as a u dash, but the refractive index of the water, the refractive index of the water or refractive index of the any medium you have to consider as a n. So therefore u dash is equal to c by n. So this is the based on the definition of the refractive index, u dash is equal to c by n you have to consider. So therefore what we have to consider, the speed of light in the moving frame, the speed of light relative to this s dash frame, how we have to calculate u is equal to how we have to calculate the velocity of light relative to s frame. This is the velocity of light, velocity of light you have to consider as a light or whatever it may be, velocity of light, velocity of this velocity of light according to s frame. Which one it is? According to s frame. How we have to write? U is equal to u dash plus v is divided by 1 plus v u dash is divided by c square. This is the formula. So from this formula you have to substitute. How you have to substitute? Once you have to see u is equal to u dash is equal to c by n. So plus v is equal to vw. This is the velocity of the water, because s dash frame is in the water is there. That's why we have to take 1 plus v is equal to vw, u dash is equal to c by n into 1 by c square. 1 c get cancelled. Therefore u is equal to, which one we have to write, c by n plus vw is divided by 1 plus vw is divided by n into c. Now you have to bring this u is equal to c by n plus vw into, so 1 plus vw is divided by nc all to the power of minus 1 we have to write. By using the binomial expansion, how we have to write? Once you have to see u is equal to c by n plus vw, c by n plus vw, 1 plus vw is divided by nc all to the power of minus 1. By using the binomial expansion, we have to write expansion. You have to see the binomial expansion. So therefore c by n plus vw into 1 minus, up to the 2 terms only you have to take, higher order terms we are neglecting. So therefore vw is divided by nc, the rest of the terms we are neglecting. Clear? So therefore you have to multiply c by n, so plus minus vw into c by n square into c, so plus vw, so minus vw square is divided by nc. This is the higher order term we are neglecting, because vw is very small compared to, so these things we are neglecting that term. So therefore we have to write here n by c plus vw, how to take the common, c get cancelled. So therefore 1 minus, so vw how to take the common, which one we are getting? vw into 1 minus 1 by n square we are getting, which is equal to u is equal to, this is the speed of, which one? The speed of light in moving medium. So therefore this formula you have to remember. This is the speed of light in moving medium, speed of light in moving medium. This is very important. Once you have to remember this one. So this is the speed of light in moving medium, u is equal to c by n plus vw into 1 minus 1 by n square is there. This is very important. Like this we have to calculate in our examination. So not only that, so in the low range transformation, how we have to discuss it in the, you have to tilt it now along the parallel, you have to tilt with angle theta. What will happen? These equations, velocity transformations equations, so those things we have to discuss here. Suppose you have to see the light beam is emitted at an angle theta with respect to x dash axis. Suppose you have to consider here a s frame. So, you have to consider this one is the S dash frame. So, two different frames you have to consider. So, now this frame is moving with the x dash axis, this frame is moving along the x axis, this frame is moving. Now, once you have to see the light beam is emitted, the light beam is emitted at an angle theta, with respect to which one? The light beam. So, that is why we have to take the two components. So, one is c cos theta horizontal component, we have to take it as a c cos theta. So, the vertical component is c sin theta, because it is resolving based on the two. So, the light beam is moving with c velocity. In which axis? X dash axis. In which frame? That is S dash frame you have to take. Find the angle which the beam makes with respect to x axis. Suppose you have to take here with respect to x axis, you have to take the theta naught, you have to consider, it is also light. So, that is why we are taking, it is also c cos theta naught. So, that vertical component is c sin theta naught, you have to take c cos theta naught, c sin theta naught, c sin theta, c cos theta, we have to write here. So, now what is our ultimate goal? So, our ultimate goal, we have to find that theta naught angle which the beam makes with respect to x axis in S frame. So, that is our ultimate goal. But you know one thing, ux is equal to ux dash plus v is divided by 1 plus v ux dash is divided by c square. This is the addition of velocities, right. So, under this addition of velocities, you have to substitute the values. Ux dash is equal to what we have to write? Ux is equal to c cos theta naught is equal to ux dash is equal to c cos theta plus v is divided by 1 plus v into ux dash is equal to c cos theta is divided by c square is there. C cos theta is divided by c square, 1 c get cancelled. So, therefore, how we have to write here cos theta naught is equal to, because the c value I am bringing to this side. So, what will happen? Cos theta plus v by c is divided by 1 plus v cos theta is divided by c. This is the expression, this is the relation between that cos theta naught is equal to. So, therefore, which is equal to cos theta is equal to c cos theta naught. So, cos theta naught is equal to cos theta plus v by c, 1 plus v cos theta is divided by 1 plus v cos theta is divided by c is there. Similarly, if you have to take u y dash is equal to, you have to consider u y dash. If you have to take u y dash is equal to, how we have to write c sin theta is divided by c sin theta, u y dash is equal to u y is divided by gamma into 1 plus so v cos theta is divided by c is there, v cos theta is divided by c, which is equal to u y dash is equal to. So, u y dash u y is equal to, sorry, u not u y dash, u y is equal to, because so we have to consider as a plus here, that is why u y is equal to I am writing. But already u y is equal to which one is there? So, that is the c sin theta naught is there, c sin theta naught is equal to c sin theta naught is equal to c sin theta is divided by gamma into 1 plus v cos theta is divided by c. So, c get cancelled, therefore, sin theta naught is equal to sin theta is divided by 1 plus v cos theta is divided by c. But we, you know the things what you know, once you have to see here, we have to take a cos theta naught is equal to cos theta naught is equal to cos theta plus v by c is divided by 1 plus v cos theta is divided by c. This is the cos theta naught value. Cos theta naught is equal to cos theta. So, cos theta naught is equal to cos theta plus v by c, 1 plus v by c into cos theta. If you have to take v e tends to c, v is equal to c, and then you have to consider as a theta is equal to 0. If v is equal to c and theta is equal to 0, so what will happen once you have to see here? So, cos theta naught is equal to you have to consider as a, so v is equal to c. V is equal to c only you have to take, so theta rather than v is equal to c only you have to consider. If you have to take v is equal to c, cos theta naught is equal to cos theta plus v is equal to c is divided by 1. So, 1 plus v by c is equal to v is equal to c cos theta. 1 plus cos theta is divided by 1 plus cos theta. So, therefore, cos theta naught is equal to 1. So, theta naught is equal to 0. So, this is very important one, right. When v is equal to c, so theta naught is equal to 0. So, from this no body with moving with the light velocity, from this also we have to discuss. Clear? So, one more important thing I am discussing to you, tan theta is equal to, how we have to write the tan theta is equal to, we have to take it as a tan theta is equal to tan theta naught into 1 minus beta square is divided by, which one we have to write here, 1 plus v sec theta is divided by c. 1 plus v sec theta is divided by c. This is the tan theta formula you have to remember. What is the theta? Theta is in s dash frame, theta naught is in s frame. You have to take, this is also important formula. So, these two formulas you have to remember, you able to get in your competitive examination. In the similarly, how the length and time is variant, in the same way I am discussing these things. Clear? Now, we have to take how the questions will come in our competitive examination. The first one you have to see here. So, two particles come towards each other. Two particles come towards each other. Two particles are coming towards each other with speed 0.8 c. With speed is equal to, how much speed is there? 0.8 c. Two particles are coming with the same speed. So, first you have to take u dash is equal to 0.8 c, and v also you have to take it as a 0.8 c. So, two particles are coming with the same, two particles are come towards each other with speed 0.8 c with respect to the laboratory frame. With respect to what? With respect to the laboratory frame. So, what is the relative speed? The relative speed is equal to, already I discussed the relative speed is equal to, how we have to write, u is equal to u dash plus v is divided by 1 plus uv is divided by c square. Just you have to substitute, u is equal to, u dash is equal to 0.8 c plus v is equal to 0.8 c, 1 plus u is equal to, u dash is equal to 0.8 c into 0.8 c is divided by c square get cancel. Now, you able to find this relative speed is equal to 1.6 into c is divided by 1 plus 0.64 1 plus 0.64 is there. So, you able to find that one, how you have to calculate. So, that is 1.6 into 3 into 10 to the power of 8 is divided by 1.64, u is equal. So, now you able to calculate, you able to get, so this is c, you have to keep like that only. You 1.6 is divided by 1.64, this one is 0.975 0.975 c it will come. So, this is the velocity, relative velocity. How we have to calculate? So, you have to calculate like this. So, this is very very important. Now, one more question you have to see. Two photons are moving approaching each other. Two photons are moving approaching each other. How they are approaching? Once you have to see, not towards the same direction. So, these are approaching each other. Now, you able to see the two particles are approaching each other. So, how you have to get that one? So, u is approaching with velocity c, v is approaching with velocity c. Now, you have to calculate the u dash is equal to how much? So, this is the relative speed you have to calculate. The relative velocity one photon with respect to other. So, the two photons, the photons are moving approaching each other because it is a photon. Photon means that is the light particle, photon means light particle. So, therefore, light particle velocity is equal to c. So, these two photons are moving approaching each other. Find the relative velocity. Already we discussed about the relative velocity. U dash is equal to u minus v is divided by 1 minus uv by c square. You substituted that value. So, u minus v is equal to what we have to write here, u is equal to c minus of v is equal to, if you have to take it is a positive, you have to consider as a negative, minus c is divided by, so the because the direction is opposite to that direction sign, you have to consider 1 minus so u minus c is c and minus c, c into minus c is divided by c square get cancel. So, therefore, what we have to get, c plus t, c is equal to c, 1 plus 1 is equal to 2. So, therefore, u dash is equal to which one we are getting? C. That relative velocity also belongs to the relative velocity. Relative velocity also belongs to whom? Relative velocity also belongs to the light velocity only. If particle is moving with the photon is moving with the light velocity, what will happen? So, that relative velocity also moving with the light velocity. The same question they are asking in the group 2 examination. In general science they are asking in this question. Group 2 examination in the general science they are asking this question. This is very very important. Two photons are moving approaching to each other. Find the relative velocity of one photon with respect to each other. In the general science they are asking. If you have to say blindly, you have to remember, if that is photon, that velocity is c only, whether it may be relative velocity, whether it may be any velocity you have to. So, because that photon will go with photon velocity only, not lesser than that, not greater than that, clear. So, this is very very important. So, maybe today is enough. Tomorrow or day after tomorrow we do not want to take the classes, and January 1st onwards I have to take the classes seriously. So, please concentrate and practice. Without practice, how many classes I have to take, how much knowledge I will give. So, that is waste of my effort, but your effort is very very important in our competitive examination. Thank you so much for making this app.